In this video, I am going to solve Edexcel International A-Level C4 questions for January 2010. And here I summarize the questions, 4 questions. I summarize question 1, 2, 3, and 5. And in the second part, I am going to solve 4, 6, 7, and 8. Here, these are the questions taken from C4 questions from January 2010. And here I am going to solve the questions. Part A. This is the summarized form. Again, I have to remind you that these are not the complete questions because I don't have enough space on the board. I summarize them available January 2010. Expand 1 minus 8x under the square root. This is equal to 1 minus 8x to the power of 1 over 2. And the expansion is going to be 1 plus 1 over 2 times minus x plus 1 over 2, 1 over 2 minus 1 over 2 factorial minus x squared plus 1 over 2, 1 over 2 minus 1, 1 over 2 minus 2 over 3 factorial minus 8x cubed. When you do the algebra here, when you work out the additions, subtractions, multiplications, and divisions here, we are going to obtain the following expansion. 1 minus 4x minus 8x squared minus 32x cubed. This is the answer for question 1, part A. B says that, show that when x is equal to 1 over 100, that expression here will be root 23 over 5. So let's do it. Root 1 minus 8x, and x is given as 1 over 100. Substitute that. 1 minus 8 times 1 over 100 under the square root is equal to, under the root, 1 minus 8 over 100. So this is 1 minus 2 over 25. It is 23 over 25 under the square root. We cannot take square root of 23, but root 25 is what? 5. Therefore, shown. This is the answer for question 1, part B. Let's do part C. Says, substitute x is equal to 1 over 100. Find an approximation for root 23. X minus 30, this is square, 32x cubed. This is the expansion. And it is given that we have to substitute 1 over 100 in place of x. So this is going to be 1 minus 8 times 1 over 100 will be equal to 1 minus 4 times 1 over 100 minus 8 times 1 over 100 squared minus 32 1 over 100 cubed. This is equal to 23 root 23 over 5, already shown. And that one here is equal to 0.959168. And how can we obtain the value for root 23? Multiply by 5. And the answer is going to be 4.79584. Yes. Do you have any questions from question 1? Do you have any questions from question 1? If you don't have any questions, I am going to take the picture send it to you so that you can revise it. Now I will continue with question 2. Again, this is the revised form of question 2. Actually, question 2 was about trapezium rule, but the first parts A, B, were about trapezium rule, but I am not going to solve trapezium rule here. And this was the part C of question 2 from January 2010 C4. But I am going to solve only integration part of the question. Here it says x ln x dx, integration of x ln x dx from 1 to 4 must be equal to something like that one. And here we need to find the value for A and B. When we have such a question, x ln x dx, because we have ln x here, we have to change the places of ln x and x dx. And remember that one here, that integration here, ln x dx, is a typical example for integration by parts. This is a typical integration by parts which can be solved by UDV that we are going to solve by integration by parts. If we have ln x is always what? U. And that expression there is going to be dv. So if u is ln x, then du over dx is going to be 1 over x. If dv is x dx, we have to find v, so we have to integrate both sides. Then that means v is going to be x squared over 2. And that is going to be uv, where u is ln x and v is x squared over 2, minus integration of v, which is x squared over 2 times du. And du is what? Here it is very easy to obtain du in terms of x. It is 1 over x dx. So here x squared over 2 ln x is equal to, take 1 over 2 outside of the integration, and x over x is x dx. So integration is going to be x squared over 2 ln x minus 1 over 4 x squared plus c. So from 1 to 4, x ln x dx is going to be x squared minus 2 ln x minus 1 over 4 x squared from 1 to 4. First step is to put 4 there. 4 squared over 2 ln 4 minus 4 minus 1 over 2 ln 1 minus 1 over 4. ln 1 is what? This is 0. ln, you have to remember that ln 1 is 0. So 8 ln 4 minus 4 plus 1 over 4 is equal to 8 ln 2 to the power of 2 minus 15 over 4. So the answer is 16 ln 2 minus 15 over 4. Let's check the answer. Yes, that's the answer. And take 1 over 4 outside of the brackets. It is going to be 1 over 4, 64 ln 2 minus 15, and that's the answer in the expected form. Do you have any questions? I am waiting for your questions from Messenger or from WhatsApp. If you have any questions, you may ask. This is the answer for question 2. And I have to remind you that these are summarized forms of questions from C4 January 2010. Now it's time to solve question 3 from January 2010 C4 questions. Let's clear the board for question 3. Yes. Question 3 is about implicit functions. We have cosine 2x plus cosine 3y is equal to 1, and first part asks for dy over dx. So we have to take the derivative here. What is derivative of cosine 2x? It is minus 2 sine 2x. What is derivative of cosine 3y? It is minus 3 sine 3y. Because we take derivative of something in terms of y, we have to put dy over dx there. And what is derivative of 1? It is 0. So minus 3 sine 3y dy over dx is equal to 2 sine 2x. So dy over dx is equal to 2 sine 2x over minus 3 sine 3y. Now p is on C where x is equal to pi over 6. Find y at p. When x is equal to pi over 6, cosine 2 times pi over 6 plus cosine 3y is equal to 1. Cosine pi over 3 plus cosine 3y is equal to 1. This is 1 over 2 plus cosine 3y is equal to 1. Cosine 3y is equal to 1 over 2. 1 minus 1 over 2 is again 1 over 2. So 3y is equal to cosine inverse 1 over 2. What is cosine inverse 1 over 2? It is pi over 6. So it is pi over 3. So y is equal to pi over 9. Now coordinates of point P are pi over 6 and pi over 9. Now part C. Find equation of tangent to C at point P. To be able to find equation of tangent line, we have to find gradient of tangent line, which is dy over dx at given x value, which is pi over 6, and y value is pi over 9. Do we know an expression for dy over dx? Yes, already found in part A. This is part A. Dy over dx is equal to 2 sine 2x over minus 3 sine 3y. So m tangent will be, gradient of tangent line is going to be 2 times sine 2 times pi over 6 divided by minus 3 sine 3 times pi over 9. So m tangent is equal to 2 times sine pi over 3 over minus 3 sine pi over 3. So m tangent is equal to minus 2 over 3. Y is equal to minus 2 over 3x plus c. And we know that it is going to pass through the point P with coordinates pi over 6 and pi over 9. Pi over 9 is equal to minus 2 over 3 pi over 6 plus c. So pi over 9 is equal to minus pi over 9 plus c. C is equal to 2 pi over 9. That means y is equal to minus 2 over 3x plus 2 pi over 9. Multiply everything by 9. 9y is equal to minus 6x plus 2 pi. So 9y plus 6x minus 2 pi is equal to 0. That's the equation of tangent line at point P to the curve with the equation cosine 2x plus cosine 3y is equal to 1. This is the answer for question 3. Check the answer. If you have any questions, you may ask, so that I am going to solve question 5 for you. Check the question here. Check the answer. If you have any questions, you may ask. I will carry on with question 5. Now I am going to solve question 5 for you, and remember, these are summarized questions from past paper of C4 from January 2010. So let's clear the board once more to be ready for question 5. Yes, question 5 says find the integration of 9x plus 6 over x dx. Remember, these are the questions from past papers. So, This is equal to 9x over x plus 6 over x dx. That is equal to 9 plus 6 over x. And the integrated form of 9 is 9x plus, what is the integration of 6 over x? It is 6 times ln x plus c. This is the integration of 9x plus 6 over x. And that's the answer for part A. For part B, we have a differential equation there. Let's write that differential equation here. It is 9x plus 6 over x, y to the power of 1 over 3. As you see, this is a separable differential equation, and it's not stated in the question, but we want the answer in the form of y squared is equal to f of x. We are looking for an answer in that form. So let's separate the differential equation. I take y to the power of 1 over 3 there and change the place of dx, take it onto the right hand side, do the integration, y to the power of minus 1 over 3 dy is equal to integration of 9x plus 6 over x dx. This one is already been solved in part A. So y to the power of 2 over 3 over 2 over 3 is equal to 9x plus 6 ln x plus c. So y to the power of y to the power of 2 over 3 is equal to 3 over 2 times 9x plus 6 ln x plus c. And do we know and we have boundary conditions here. When x is equal to 1, y is equal to 8. Let's substitute 8 for y, 1 for x to be able to find the value for c. When x is equal to 1, we already know that y is equal to 8. So, this is 2 over 3. 2 over 3. It's not 1, 3 over 2. So, plus 6 ln 1 plus c. This is 0 because ln 1 is 0. Yes, this is 4 is equal to 2 over 3, 9 plus c. So 6 is equal to 9 plus c. C is equal to minus 3. That means y to the power of 2 over 3 is equal to 2 over 3, 9x plus 6 ln x minus 3. And we want the answer in the form of y squared. So I am going to take cube of both sides. So y squared is equal to 8 over 27 9x plus 6 ln x minus 3 cube. That's the answer for question 5 part B. Yes, do we have any questions? Yes. Tomorrow we are going to finish January 2010 C4. Tomorrow I am going to solve questions 4, 6, 7 and 8 for you and complete this past paper. And from now on we are going to continue with past papers so that we finish pure mathematics for P4. Remember, we don't have any P4 past papers. This is going to be the first one. Only we can use C4, past C4 questions to be prepared for P4 exam. Although you are not going to have it, they all cancelled P4. But let's learn what is included in P4 by solving some past papers from C4. Bye bye from me from now. See you tomorrow at this time at 4 o'clock. Bye.